All right. This is section 8.1, hypothesis testing. Um, hypothesis, they call it an assumption. Oftentimes, you hear hypothesis is an educated guess. So, an assumption or a guess of what you're predicting, right? If you're getting a B on every test, then you're going to assume or guess that you're going to get a B on the next test. A hypothesis is an educated guess based on the information that you have. Uh, and it may be true or it may not be true. You might get a B on the next test, you might not. So all it is a guess that may or may not be true. That's not anything definitive. So there's two types of hypothesis we're really going to talk about. The null hypothesis, and once again, hypothesis is just a guess of what's going to happen in the future, and we indicate the null hypothesis with an HO. That's called the null hypothesis. And it's a guess. Once again, you can, instead of hypothesis, you can say it's a guess. It's a statistical guess that states there's no difference from the parameters to a specific value. Okay. In other words, there's no difference between what we say is going to happen and what actually happens. A null hypothesis. Um, there's no difference between a parameter, a set of parameters, and a value. Alternative hypothesis. I'm trying to get my pen back. Sorry. There we go. Alternative hypothesis is indicated by a H1. Sometimes it's an HA, but I think in this book we're using H1 just in case in the homework they use HA. The alternative hypothesis is HA or H1, and it, once again, it's a guess, but there is a difference between the parameter and a specific value. So the alternative hypothesis means there's a difference. If the null hypothesis means there's no difference in the values, the alternative to no difference is there is a difference. So the alternative hypothesis means there's a difference between your parameter and the value that you're talking about. So null, there's no difference. Alternative, there is a difference. And you'll see in the homework, the first few homework questions, and I won't be doing those, deal with definitions and stuff. So when we say a two-tailed hypothesis, we always draw the normal curve. And a two-tailed hypothesis has a shaded area on both tails of the normal curve. Do you see? It has a shaded area on both tails of the normal curve. And let me just show you how we would write this. A researcher knows that the pulse rate is 82. Our null hypothesis is our pulse rate, our mean, our average pulse rate is 82. So there's no difference between the parameter and what's happening. There's no difference. It is 82. It equals 82. Our alternative hypothesis is that it does not equal 82, right? The alternative to that it is 82 is not 82. So just want you, we'll be doing this also on Wednesday in 10.2. So just know if the null hypothesis, there's no difference there, it equals 82. The alternative is it is not 82. And this is how we draw a two-tailed hypothesis when we're using a normal curve. We have a tail here and a tail here, two tails. Hopefully this comes together. I mean, it really won't come together. A lot of this won't come together until we do 10.2, because there's a little bit more we learn about this in 10.2. Now, look at this next one. It says a right tail. In other words, you have a normal curve, and only the right side, the tail of the right side is shaded. Right tail hypothesis. The mean lifetime of an automobile battery without the additive is 36. So the null hypothesis is the mean is 36. However, remember the alternative hypothesis is the opposite. The null is what it is. The alternative is another way of looking at it is what a scientist is trying to figure out. And here it says this chemist invents an additive to the battery, and he wants to increase the battery's life. So the alternative is, if the battery's life is 36 months, he wants to increase. So he's hoping that this additive increases the battery life. In other words, that the mean, which is 36, is greater than 36. He wants to verify that the mean is greater than 36 because he's adding an additive, and he wants it to be more than 36. So the right tail talks about an increase or more. A right tail is you have more of something, an increase. So the null hypothesis equals is 36. The alternative, what the scientist is trying to prove, that when he adds this additive, that it will be greater than 36, that the battery will last longer. Okay. Left tail hypothesis test. Contractor wishes to lower heating bills by using a specific type of insulation. He wants his heating bills to be lower. So if I do a normal curve and we're going to do a left tail, the left side is shaded in the tail. Do you see the null hypothesis is 78. The heating bill, the average is 78. The alternative here is he wants to lower the heating bill. If my heating bill is $78, this scientist is trying to get it. We're going to try to do something special insulation to try to get our bill less than $78. So a left tail hypothesis deals with less than, a smaller amount than our average. Anything that's smaller than our average is called a left tail hypothesis. Our HO, our null hypothesis, is equals, and then our HA is less than. So on the test, this often people get confused on the test. On the test, there's only 3 possibilities to write HO and HA. The first one is HO, the average equals, and HA, the average does not equal. Number 2, HO, the average equals, HA, the average is greater than, and number 3, HO, the average equals, and HA, the average is less than. These are the only 3 possibilities for picking an answer. So if you had an answer that looked like this, HO, the average is less than, and HA, the average is greater than, that you know that can't be an answer. These are the only three possibilities that you can have. These are the only three possibilities that you can answer any of these questions. And once again, you really won't get the full gist of this question until we do 10.2 on Wednesday. So I would write these three down and know that you can only use one of those three. All right. So we can read through this really quick. The claim: when a researcher conducts a study, he's generally looking for evidence to support a claim. Therefore, the claim, what the scientist is trying to claim, is the alternative, the H1. Am I writing HA? Remember, alternative, I mean, some books it's HA, some books it's H1. I'll start using H1 again. But the alternative is H1 or HA. So that's the scientist's claim. Whatever, there's a set standard, but then whatever the scientist is trying to get it better or worse or just different. Okay. After studying the hypothesis, researcher next step is design a study. I'm not too worried about this. All this stuff you can actually read through. Hang on, what is this? I'm trying to find. And once again, in here, we can just highlight a couple things. A claim, though, can be stated as either the null hypothesis or alternative. However, the evidence can only support a claim if the alternative, if it is the alternative. So the evidence can only support if the alternative is the claim, is what the scientist is trying to figure out. You can reject the claim if the claim is the null hypothesis. So we're going to talk about rejecting and not rejecting here in a little bit. So I wouldn't read into this. I mean, it's a little confusing, but we will actually talk about this today when we get down just a little further. I'm trying to get this stuff erased. Hang on. There we go. Okay, so down here in the hypothesis testing situation, there are 4 outcomes. So here are the 4 outcomes. There's 1, 2, 3, 4 possible outcomes. If you're going to do an HO and an let me raise this up just a little so you can see the full square. Oh. You're going to do an HO and you're going to do an H1. HO is always equal. If you looked at the 3 ones that we had, they're always equal. Now, once again, the H1, the alternative, can be not equal, can be greater, and can be less than. There's no equal sign allowed in the alternative. Only the top HO has the equal sign. If you're doing some calculations and the HO is true, let's say your car oil lasts 3 or 12 months, right? You're saying your car oil lasts, there's going to be an example later on. Your car oil lasts 3 months and it does not last 3 or 12 months, and it does not last 12 months, it only lasts 9 months, then you can reject the HO. So if the if the HO is true, if the oil, well, here it is. If the HO is true, if you say the oil lasts 12 months and it does last 12 months, but you say, no, I reject it, I don't believe it, but it does last 12 months, but you say, no, I don't believe it, that's called an error, a type 1. If something is true, if the HO is true and you say it's not true, we call it a type 1 error. Now, if the HO, if the initial, your null hypothesis, if you say it lasts 12 months, but the oil goes bad after 3 months, and you say, oh, my oil is good for the whole 12 months, but it wasn't, that's called a type 2 error. That's called a type 2 error. So a type 1 error is if the null hypothesis is true and you say it's false. The type 2 error is if the null hypothesis is false, but you say the statement is true. And look, if the null hypothesis is false and you say it's false, it's a correct decision, right? If you say the oil is going to last me, it's not going to last me 12 months, and it doesn't last you 12 months, or it's going to last me 12 months, and it doesn't last me 12 months, that's a correct decision. You say it doesn't. Or if you say it's going to last you 12, well, if you say it's going to last you 12 months and it doesn't, it's a type 1 error. If you say it's not going to last you 12 months or it does last you 12 months and it doesn't, I'm telling you, that's really confusing. If the null hypothesis is false and you don't reject it, you don't say it's false, then it's a type 2. There's actually a better scenario right below this to explain it, is about going to prison and all. Down here. Okay, so here's a person that's on trial for murder. Let me go up a little bit. So this is the type 1 and type 2 errors. A person is on trial for murder, okay? And they did not do it. They're innocent. But the jury found them guilty. If they're on trial for murder and they did not do it, but the jury found them guilty, that's a type 1 error. So that might make a little bit more sense. Now, if you're on trial for murder and you did it, you are guilty. And the jury says, you're guilty. Everybody knows you're guilty, but the jury says you're not guilty. They made a bad decision. The guilty man is found not guilty. That's a type 2 error. So if you're innocent and you're found guilty, that's a type 1 error. If you're guilty and found innocent, that's a type 2 error. Now look at this. If you're guilty, if you did it and you're guilty and you are guilty, they found you guilty, that's a correct result, right? If you're guilty and they found you guilty, that's a correct result. Here, if you're innocent and they found you not guilty, that's a correct result. The only way you get a error is if your null hypothesis it didn't come out to what your alternative was. You did not do it, you're innocent, but you did, the jury found you guilty. That's an error. It's called a type 1 error. And then a type 2 error is if you are guilty, but they found you innocent. So I would take a look at this a little bit and focus on the type 1, type 2 error. There's some questions in the homework. I'm not sure if they're on the test about the type 1 and type 2, but I would stay focused on just those two. See the difference between these two. This is an innocent man that's found guilty, and this is a guilty man that's found innocent. And these are just more of the same thing. I don't know why they have all those extra squares. So the level of significance deals with Z values, type of significance, the levels of significance. You can have 10%, 5%, 1%. Oh, how did that? Uh-oh. What happened?
Likewise, P type 2 error equals beta. Typical significance levels are 0.1. Guilty man is found not guilty. Trial results. Reality. Math.
All right. I got that. Now I got to get the workbook back. I must have hit the talking part. Let me get the workbook back. Because we got some important part to cover now. Where is the workbook? There it is. Just trying to bring the workbook back up. Oh, it said read aloud. I must have clicked on it by accident. Oh, by the way, don't if you noticed last week to find n, I think I showed you the equation wrong. I put some new videos there, so you should be able to see those new videos. Okay, so here, that read aloud thing is really close to this. That's why I did that. All right. Let me share it again. So a critical region. So we're the level of significance and critical region. Oftentimes we use this symbol, and we call this the alpha. This is the type 1 symbol, the alpha symbol. And for example, alpha is 10%. We use a decimal equivalent. And we're going to actually have to find those Z values. So let me draw a little picture here. So here's our normal curve. As let's say we have a right-tailed test. This is called the critical region. We call it the critical region or the rejection region. So they're called both. If our value lies in the rejection region or the critical region, then the null hypothesis should be rejected. If our value lies somewhere else, this is the non-critical or the non-rejection region, then the null hypothesis is not rejected. So if the null, and I would definitely like make a special note of this, if the value that we're looking at, if the value is in the critical region, you should reject the null hypothesis. And if the value that we have, let's say the value is here, it's not in the critical region, then you do not reject the null hypothesis. Rejecting the null hypothesis means, hey, I don't believe it's equal to. Remember, null hypothesis is only equal that the mean equals the average equals this number. The null is always equals. So if it's in that region, it should be rejected. If it's not in that region, it should not be rejected. So if we look at this, find a critical value for alpha 0, 1. So we know how to do this already. This is a right-tailed test. You see the shaded is in the right tail. We need to find the critical value. We need to find the Z value for that, this spot right here, that shaded in 1%. Does anybody know how to find that critical value for that spot? The Z value? Oh, I'm going to use my calculator. How do I find a Z value for a shaded in region? If you remember, we have to use second vars number 3, inverse norm. Remember, inverse norm only goes to the left. So to find this Z value, since this is 1%, then the rest of it is 99%. So to find the Z value at this spot, we have to type in second vars inverse norm. The area is 0.99. Remember, your inverse norm only goes to the left of the Z value. So to the left of this Z value is 99%. So on my calculator, let me show you. Second vars, or I should have just said second vars number 3, inverse norm. And we're going to type in the area. Oh, I clear that, 0.99. And leave your average at 0. That's your Z value is 0. Standard deviation is 1. And when you type that in, hit enter one more time. And 2.33 is your Z value, 2.33. So since this was 99% that way, we did second vars number 3, inverse norm. and we typed in 0.99, and we got a positive 2.3. That's our critical value. So remember, you reject the null if you ended up with a 2.41. If you ended up with, that's our z value here. If you end up with a z value anywhere in here, you reject the null. Reject the HO. If you get a z value, if you get a value over anywhere in here, you do not reject the null hypothesis, the HO. All right, so you'll have to do this on the homework and the quiz. It's just, we've done that inverse norm a couple of times. And they tell you use the table. Anytime the book or something tells you to use the table, don't use it. Do you see how they get 2.33 on the table? There's 2.3 and then the 0.03. So this is 2.33 as 99%. So there's a big table you can use, but we use our calculators. A left-tailed test at 0.01, we have to find the z value. Now, remember, since it's the shaded part is to the left here, if we didn't know this, we just type in 0.01 and you'll get negative 2.33. So because once again, it's on the left-hand side of 0, all the z values are going to be negative over here, negative 2.33. So type in 0.01 on the inverse norm, and you should get negative 2.33. Second vars, number 3. And 0.01 was the area to the left, and you get negative 2.33 when you round it to 2 decimal places. Now, some people mess up this next one. Hopefully not. A two-tailed test. A two-tailed test. It says the critical area is 1%, 0.01. It's 2, but since we have 2 tails, it's not 1% on both sides. You have to cut the 1% in half. So 0.01 divided by 2 is 0.05, 0.005, and 0.005. Do you see we have 2 shaded regions? And they are symmetrical. So if we find one, we know the other. One's negative, one's positive. So on our calculator, we're going to go second vars, number 3, and we're going to type in 0.005. And that should give us this one, 0.005 to the left of this number. It'll give us a negative z value. And when I do that on my calculator, second vars, number 3, 0.005, I get a z value of negative 2.58 when you round it off to 2 decimal places. So if you did it on this side, you get the same thing, 2.58, but positive. I mean, you can also, on your calculator, to get the same answer, you can type in 0.995. Which is, because this part is just 0.005. So 0.995 is shaded everything that way, and you would get 2.58. So the left side is negative 2.58. The right side is 2.58. A 1% critical value, you have to cut it in half. If your critical value was 10%, then it would be 5% both sides. If your critical value was 4%, then it'd be 2% both sides. And you'd have to do your calculator accordingly. And here's just a little bit more. It says left tail test the critical value region will be on the left. A right tail is going to be on the right. And the two tail test, you're dividing it in half on both sides. Find the z-scores. That's what we did. So here they don't draw the picture, but we can do this. Find the critical value for each of these. A left tail test where alpha is 10%. So you just put 10% in your calculator, 0.10, second vars, number 3, and type in 0.10, 10%. Second vars, number 3, 0.10, and you should get a critical value of negative 1.28. That's the z value right here. Uh-oh. If you have a two-tailed test, and the alpha is 0.02, two tails, you got to divide it by 2, you get 0.01 and 0.01, and you have to find the z values for both of these. We know the one on the left is going to be negative, so you do a z value for 0.01, second vars, number 3, 0.01, and you get negative 2.33. Then the other side, you're going to get a positive 2.33. And you can do that once again by typing in this one and putting it on both sides. Or at this point, you can type in 0.9. Oh, 0.01. I typed it in wrong. 0.01. There we go. You can type in 0.99. Because 1 minus 0.01 is 0.99. And you would get the same thing. 0.01, you get a negative 2.33, and it's symmetrical on the other side, or you can type in 0.99 because this whole side would be 99% if that's just 1%. And that's that. You can go through the read the rest of that. So we're not covering 8.2, just 8.1. And there is no 8.2 in this course anymore. So let me hit stop recording, and then I'm going to go to the homework.